Okay, go ahead. We are live now.
Thank you so much, Amit. Thank you so much. And good afternoon, very good afternoon, dear ladies and gentlemen, dear attendees, delegates attending this program of joint program of ASSOCHAM Jam Green Building Council and ISLE, Indian Society of Lighting Engineers. So, friends, you all know that ISLE and ASSOCHAM Jam Green Building Council are jointly organizing the programs on lighting design. So this is our fourth program in the series. Our last three programs were wonderful, and many attendees attended those programs. Today also we can see very good attendance in this program. So thank you so much for joining us on this Saturday afternoon. Thank you so much. Today's topic is LED technology roadmap. And we have eminent speakers from India and abroad on those who will be talking on this subject. Starting with, we have Mr. Balaji MV, who is the head technology development in Hynetic Electronics Private Limited. We have with us Mr. Stephen Dhale, who is the member of the board, LMT GmbH Berlin. We have Mr. Satyabrat Chakravarti, consultant, lighting, technology and educationist. We have with us Dr. Prakash Barjatiya ji, who is governing body member and director, Indian Society of Lighting Engineers. And myself, Neeraj Arora, senior director at ASSOCHAM. So we all welcome you on behalf of ASSOCHAM to this wonderful program. And I'm sure with these speakers, this will be a very interactive, very knowledgeable program. And after the program, once the presentation will be over, we will take the questions from the audience. So I will request the audience to please put your questions in the question box so that we can take the questions at the end. Now, I will not take much of your time and would request Dr. Prakash Barjatiya ji for his special address. Prakash Barjatiya ji will talk what ISLE is doing, what ISLE has already done, and what ISLE is doing during this COVID situation, and what are the future prospects of ISLE. Dr. Prakash Barjatiya ji is an electrical engineer by profession and is actively involved in conducting programs, seminars, workshops, various workshops on LED and solar and those things. Having worked with the Central Institute of Road Transport, CIRT, Pune, and associated with the Battery Society of India, he is also very active in e-mobility. He is very passionate about his work, and he has recently completed his PhD at the age of 65. So this shows his passion towards learning. Thank you so much, Dr. Prakash Barjatiya ji. And we would like to listen from you. Over to you, Prakash ji. Prakash ji, unmute yourself.
Yeah. Thank you, Mr. Welcoming all the speakers for this afternoon session, jointly with the Indian Society of Lighting Engineers. I also welcome all the participants in this program. On behalf of ISLE, I welcome everybody. And with this, I just take a privilege to introduce about the ISLE. It is a professional body of scientists, engineers, architects, academicians, researchers, designers, students, and all others interested in the subject of lighting. This is a body which is completed 37 years. And although its name is lighting engineers, but its membership is open for anybody who is interested in the subject of lighting. With this background, what our aims and objectives is promoting the art, science, and practice of lighting technology, advancing education and research in lighting technology, formulating lighting codes, guides, and technical reports, maintaining liaison and technical interaction with national and international organizations, cooperation with the Bureau of Indian Standards, and providing guidance to young engineers for their career improvement. Now, our vision of the ISLE is the National Lighting Code. In line like National Building Code, there is a National Lighting Code also which is there, which was formulated about 10 years back. And now it is under revision because any standard, it has got its limited life because of the technological advancements. So now National Lighting Code is under review under the able guidance of our Honorary General Secretary, Dr. Rajat Mandal. Our next vision is about the setting up a National Lighting Center, a Center of Excellence, as in the lines of LRC US. We are also working towards the certification for lighting in the field of skill development, and that's why we launched in the particularly during the COVID period, we launched the e-certificate course in basics of lighting and illumination, and now we are running a course in the lighting design. Similarly, we conduct a lot of programs for the awareness program for students on energy saving. Subsequently, we are also involved in the starting PG program, degree, diploma, certificate courses in lighting and illumination. ISL is operating through 7 state centers, that is all 4 metros, Delhi, Chennai, Calcutta and Mumbai. Then there are 3 other centers at Rajasthan, at Jaipur, then Karnataka at Bengaluru, and Madhya Pradesh at Indore. Then there is a provision of local centers. So there are 4 local centers there, one at the Pune local center under Mumbai State Center, then 2 local centers under Calcutta at Bhubaneswar and Guwahati, and another local center at Hyderabad. Then again, under all these, there are 17 student chapters throughout the country, which are 4 student chapters are under Rajasthan, 1 at Indore and Madhya Pradesh State Center, 7 student chapters under Mumbai State Center or Pune local center, and Karnataka there are 2 student chapters, and in Calcutta there are 2 student chapters, and in Chennai there is 1 student center. Like that, total there are 17 student chapters through which we are promoting the awareness on the lighting education. We are closely working in association with the Bureau of Energy Efficiency, Bureau of Indian Standards, Power and other government agencies. Internationally, we have got affiliation with the ISNA, that is Illumination Engineering Society of North America, Lux Pacifica, Institution of Lighting Engineers, IES, the Lighting Society, and also the SAARC countries. The governing body member presently, which is for the tenure of 4 years, which is led by Mr. Dilip Kumar, who is the president, and he is the CEO of K-Light Group of Industries. Then we have got Mr. H. Mukherjee as Vice President, Dr. Mandal as Honorary General Secretary, Mr. Balasubramanian as Honorary Treasurers, and then there are 4 directors are there for different activities, and there are 7 members who are the members of the governing body. Then, as I mentioned, our first important activity is National Lighting Code drafting. Now it is under review under the guidance of Dr. Rajat Mandal, Honorary General Secretary. And this National Lighting Code is being formulated under BIS. So BIS has given this responsibility to ISLE. As I mentioned that accepting the challenge of COVID, we started a 6-month e-certificate course in basics of lighting and illumination on 25th of May 2020. And so far, we have conducted 54 lectures under this program. Now, this program was initially conceptualized and started Mr. Kamal Setia, who is the chairman of Calcutta Student Center and also the director, exhibition and conferences. For this course, who are supported by us, this program, Dr. Amardeep Duggar from Chennai, Mr. Tapan Kumar Ghoshal from Calcutta, Mr. Sten Alvarez from Mumbai, Mr. Uttam Saxena from Lucknow, and Mr. Kiran Gogoli from Delhi. So with this, we started this, and there is 76 registered participants, not only from India, but also from Africa and the Saudi Arabia. Under this program, a very interesting thing happened that on our request, the ISNA has accepted to organize the lecture programs, and under the same one topic, that is light for life, there are 20 lighting experts. They gave 17 presentations from 15 partner organizations and 13 countries on 27th and 28th of July. This was a wonderful session and it was very much successful. Again, in the same program, we had the honor of getting the global leaders, or you can say world leaders in the field of lighting. One is Professor Bommel from Netherlands, is the chairman, emeritus professor. Another emeritus professor, Dr. Warren Julian from Australia. So we had this, and then subsequently we had a few distinguished speakers apart from others, Mr. Amarjit Duggar, Sudeshnaji, Supankhopadhyay, Dr. Kulkarni, Mr. Raja Mukherjee, then Mr. Ghosh, Rai, Vishwanath Rai, Mr. Chakravarti, who is there today also, the speaker, and Mr. Anil Walia, who is the educationalist. So apart from this, we had so many distinguished speakers. I mentioned you that apart from that course, we also started recently from 14th of September, 14th October, computer-aided lighting design course, which is recognized and approved by Electronic Sector Skill Council of India and also with the ASSOCHAM GEM certification. And another important activity that, particularly in this time of COVID, there are a lot of products which are being sold under the name of UVGI. So, but then they are not up to the standard, and then it is having a bad effect on the health. So, to control on that, ISLE has prepared with the help of some 8 experts from the field, ISLE position statement on germicidal ultraviolet irradiations, and we have requested BIS to formulate a safety and performance standard on UVGI on behalf of IS. So with this, and those who are interested, they can approach us, and we will be happy to share this position statement document with them. And one of the important things happened during this COVID period, that ASSOCHAM and ISLE together, and we signed a MOU on 15th of July. It was a very good day, and then we signed, and then subsequently we are conducting so many programs. So first program was held on 15th July itself, which was participated by about 1,400 participants from all over the world. Next program was again on 29th July. That was also participated by 150 participants from all over the world on the landscape illumination. And next program was here about the GEM sustainability, which was on 8th of August, and was addressed by lighting designer from Pune, Mr. Kostum Nandurbarkar. So this was all important. Then subsequently, we had a very interesting session on light and untold story on 30th September by Mr. Abhijit Salunke, which was sponsored by A Light Group of Industries, and was addressed by Shamila Kumbhar, Director of the Market Development. Then last week, we had on 10th of October, again in the series of LED, a session on LED market consolidation and challenges, which was addressed by Mr. Raja Mukherjee, the Senior Vice President and Business Group Head of the Panasonic Light Solutions. And another expert, Mr. Ravi Avi, is the CEO of Messrs. Go LED Tech, who is also the ex-Nisha person. And it was very interesting presentation with a lot of question answers at the end. And we are happy to introduce today that today we are going to again in the same LED series. There is another event in the LED technology roadmap, which is going to be addressed by Mr. Stephen Dale from the LMT, Mr. Balaji, who is the head technology, Hyneric, and Mr. Satyavarti Chakravarti, the consulting lighting. So with this, as we also publish our Light India magazine, LII, every 2 months, and the e-copy is available. As I mentioned, our main activity is the education and training activities. With that, we have got 17 student chapters across India. In fact, from the beginning of the history of ISLE, ISLE is involved in promoting education in the country, starting from the MTech program in the Illumination, which was started in Jadavpur, which was supported by 1993 by ISLE, and again in Manipal in 2003, and MIT School of Energy and Lighting, Pune, first ever techno-manager PG program in lighting technology and energy management was started in 2007. Then in 2013, under the Mewar University, we started a LET UK diploma course. Then lighting design module was introduced in PG program in architecture at Bharatiya Vidyapith Deemed University, Pune. So with this brief introduction on lighting activities, today we have got 994 student members in 17 ISL student chapters in engineering and architecture colleges. Now, student chapters, the basic requirement that we must have minimum 25 student members, and life membership is very nominal, some 500 rupees for their minimum per course for 4 years tenure, and if you want to become only for 1 year, then 300 rupees. Nominal fees. But we want to give a lot of benefits to the students, exposure to the subject of lighting, activities, help in projects, help in placement, discount in events organized, supported by ISLE, and also the e-copy of ISLE newsletter. These are the benefits which are given to the students and all members. This is a very minimal fees is there for any organization. So I appeal to all those who are participating in this event and they are not members, that please become the members so that we can take up more and more activities in the field of lighting. Because lighting is now not restricted so far only to the bulbs and the tube lights. Now lighting is entirely different. It is not only for illumination, but it has got a multifaceted role. So I appeal to all those who are not members to become ISLE members, get enlightened, and let us interact. With this, I thank you very much, everybody. Thank you.
Thank you so much. Thank you so much, Prakash ji. Thank you so much. Amit, next slide, please. Yeah. Yeah. So next we have with us Mr. Satyabrata Chakravarti ji, who is the consultant lighting technology and educationist. Mr. Chakravarti has over 40 years of wide-ranging experience in the lighting in India. He has served in senior role for several organizations such as Bajaj Electrical, Surya Roshni, and Crompton Greaves. He has an MTech from University of Calcutta. His areas of expertise include technology, training, lighting design, setting up of lighting laboratories, quality control. He led the first LED Luminaire Committee for Bureau of Indian Standard as chairman and has provided leadership at various national and international forums, panel members, CIA technical committees, etc. Apart from being a keynote speaker at CIA, Mr. Chakravarti presented paper in national and international conferences. So with this, I would like to invite Mr. Chakravarti for his special address. Chakravarti sir, over to you.
Thank you, Mr. Neeraj. Today, the subject what we are going to discuss is the LED technology roadmap. Subject of the lighting has been understood by few, misunderstood by many, ignored by most, but it influences all. This is a situation we are working with lighting. So when we talk about the lighting technology roadmap, it is a challenging task. Now our program, the way we have drafted our program, that we have one of the international expert, Mr. Dale. He is from LMT. Mr. Dale, he will talk on the measurement, basically for the photometric measurement. And after Mr. Dale's presentation, it will take over by Mr. Balaji. He will talk on smart lighting. And once this presentation gets over, then last will be my presentation. And my presentation subject will be LED technology roadmap. And we request all the participants to, you can write down your question, and at the end, after the three presentation, we will answer all these questions. Now, before I hand over to Mr. Dale, I request to Amit Kumar to show. Mr. Stephen Dale has been responsible for global business development for the light measuring instrument manufacturer, popularly known as LMT. LMT is the leader in the photometric measurement in general illumination as well as automobile illumination. I'm interacting with him during my days with LMT and to Mr. Dale in Crompton Greaves, Surya Roshni, Bajaj Electrical, and also in Panasonic. So after Dale's presentation, it will be over to Mr. Balaji. Now I request Mr. Dale to take over.
Dale, please unmute yourself. Yeah.
Am I unmute?
Yes.
Should I are you there?
Okay, I think we have it now. Yeah. Okay. Are you seeing my presentation? Good.
Yes.
Okay. Thank you to all of you, especially Chakrabarti-san and Rakashan-san, for inviting me to speak today. I would like to speak about recent developments in the goniophotometry of automotive and general lighting. We are experts in the field of goniophotometry. Our company is in Berlin. For those who do not know us, we have been doing this for 40 years, building full-scale goniophotometric laboratories for automotive and general lighting, with exporting all over the world. At the moment, about 325 automotive systems worldwide and 160 full-scale general lighting laboratories. In India, we've had very good success, and India remains one of our key countries, where we have sold, you will find A-type goniophotometers for measuring automotive lighting. 15 units are now in operation. Mr. Prakashan-san from CSIR has been using one of these machines for, I think, at least 30 years now. And this machine is still running fine at CSIR after so many years. C-type goniophotometers are our other specialty for general lighting testing. And in India, we have now 14 systems installed, I think everywhere at the top level. The most recent, the first system was purchased together with Chakrabarti, I think also about 40 years ago when our beginning. And the latest system was sold to the National Physical Laboratory. This system will be flying to Delhi next week. It's being packed here at LMT this week, and middle of next week is the flight of the cases to Delhi, and soon NPL will have also a top-of-the-line, state-of-the-art goniophotometric C-type laboratory where they can produce the typical information that the Indian lighting engineers require to remain innovative and to produce high-quality products. Lighting products, those are the photometric quantities, the IES and Oled files. Those are all of the electrical characteristics of the luminaire under test. The goniophotometer will also be able to convert automatically into a goniospectral radiometer, and with this we can test high-speed color over angle characteristics, and all of the commonly employed flicker characteristics will also be able to be tested at NPL. Today I'd like to just speak, I want to try and emphasize the role of LEDs in recent developments in pushing goniophotometric development. But I'd like to cover just a few sort of interesting fields right now of question. One, it would be UVC gonioradiometry. Another one, I'd like to show the latest development of a robotic goniometer, which can be an ABC type goniometer. Then I would go in shortly and show the newest development, which is related to the rapid advancement of LEDs in automotive lighting, requiring high-speed goniophotometers. And then I will just touch on the next development in goniophotometry, which is going to be for automotive lighting, which is going to be real car goniophotometry. I think it's because of COVID, it's important. Maybe you're interested in just seeing our opinion about UVC gonioradiometry. As Dr. Prakash Sansan has intimated, UVGI is at the moment a hot topic. The idea is that UVC can be used as a germicidal fixture, and there has been quite a bit of interest in using gonio photometers converted into gonio radiometers to test UVC distributions. This is something that needs to be, as Dr. Prakash Hasan has said, it needs to be taken with great care and great preparation before you start going into this. Where UVC radiation gonioradiometry is interesting is for the upper room UVGI. These are luminaires that are mounted at the at least 2 meters above below the ceiling or above the head level of people in the room, and they are emitting UVC into the air and providing a sort of constant disinfection. Before anyone gets into this, they need to read, in addition to the Indian report of the ISLE on this, also an IES committee report on germicidal ultraviolet radiation, and a CIE guide for measurement of upper air ultraviolet germicidal radiation. That's right now a technical report in draft phase. I don't know if it's been issued yet, but it should be issued soon. And the main thing about the most important thing about these documents, or familiarizing yourselves with these documents, is they go into depth about the risks and safety precautions that need to be taken when you're doing UVC photometric or radiometric measurement. Again, the idea of these UVGI luminaires is they are mounted above head space in a room, and theoretically they are disinfecting all of the air in that room that is being transported through this radiation. Because it's over the head of the people, then it's apparently not going to be dangerous to the people and in the room, and they don't have to wear masks, and everyone can have a good time, as you see in this photo. This is a sort of a typical luminaire. They are emitting 2 pi type radiation, and what we need to know is the beam spread of the radiation and the dose over the length of the spread. And this is something that can be done with a goniometer that has been converted into a UVC gonioradiometer. You can use a typical C-type goniometer. That would be a mirror-type goniometer, in which case you must do a direct test, or you can use A or B type goniometers where there's no intermediate mirror. You need to have a UVC sensor connected to the goniometer instead of a photometric sensor, which is in the moment what is being commonly used. Theoretically, you can use a spectral radiometer that is sensitive in the UV area, but spectrometers are very slow with the gonioradiometers. That's not a very effective way of doing it. You need a suitable room. You need to consider that black surfaces do not always reflect UVC or might reflect UVC. It's difficult to tell. That means you have to maybe convert the stray light measures in your typical gonio photometric room. and you have to make sure that the operators and the material in the room is not exposed to UVC. This would be a typical UVC adapted radiometer that can be connected to a goniometer and do a distribution test, a UVC distribution test in about 250 readings per second. There are complicated formulas given in softwares to calibrate these systems. LMT provides a software with its systems for doing this, for calibrating. But in the end, after you familiarize yourself with the documents concerning UVC radiations, you need to consider the following. First of all, on mirror goniophotometers, mirrors will not reflect UV. That means you have to cover the mirror. What is recommended is with a highly polished aluminum sheet, and then do the test via this covering of the mirror. Glass UV will not be reflected via the glass, so you have to put this aluminum sheet over the mirror. This type of handling, if you have a high quality mirror goniophotometer, you probably don't want to be messing with the mirror, dealing with the mirror in this way. So we do not recommend this. Better would be to use a or B type goniometer where there is no mirror, that the radiometer sensor is directly in a direct access to the goniometer without an intermediate mirror. Prolonged exposure to UVC causes significant material deterioration of equipment surfaces. It means if you have an expensive C-type mirror goniophotometer, you really don't want to be exposing components of this goniometer to UVC radiation over long periods of time. It's going to deteriorate the material very quickly. Handling of UVC requires very strict worker safety protocols and suitable laboratory infrastructure. Basically, you have to reconfigure the laboratory so that UVC radiation is being emitted at all times only in regions that are not where there will be no workers, or where the surfaces that are going to be degraded by UVC exposure are suitable. And again, you have to do a complete new stray light assessment of your laboratory. That means a typical conventional black darkroom used by conventional goniophotometers might not be suitable. So it's possible to convert your goniophotometer into a gonioradiometer to do these UVC distributions of UVGI lamps, where distribution information can be helpful for good planning, but it's something we don't recommend. We recommend that if you consider doing this kind of testing, that you use a dedicated UVC gonioradiometric system in a dedicated laboratory with dedicated safety precautions. That's quickly to the UVC issue, as we've been having many questions about this. The development of LEDs has pushed the development of goniometers over the last 10 years. That means goniometers need to be quicker. They need to have to handle different sized objects than traditional objects, because the LEDs have given us a much greater freedom of design. One issue that has been under discussion is it not possible to convert a conventional industrial robot into a goniophotometer? Yeah? The main problem in doing this is that the IES LM7919, that's also the standard that controls the Indian market. Basically, the Indian market is oriented on the IES LM79. This requires that the test object always be measured in its dedicated burning position throughout the test with respect to gravity, and that the gravitational orientation does not change during the test. Now, a robot is going to do that. A robot cannot maintain, with respect to the sensor, the dedicated burning position of the luminaire. As you see here, this is actually a downlight that is mounted on this robot. And if you just do a horizontal axis through the mounting arm of the goniometer through the light source, you will lead to the photometer. And in this case, the light is being not measured in its dedicated burning position. 025, test method for LED lamps and LED luminaires. This does allow measurement out of the dedicated burning position. So for markets where this is possible, a robotic system might be quite interesting. The challenge, however, is to develop a single goniometer based on an industrial 6-axis robotic platform, which can cover all goniometer typologies. That means movement as per A, B, and C planes, an A-type goniometer, a B-type goniometer, a C-type goniometer in one system. That also requires that it moves on 2 axes and not on 6 axes, that it can do on-the-fly measurements, that it has an angular accuracy of 0.01 degrees, that it can handle a wide range of lighting fixture types, sizes, and weights, and that because it's a robot, you can possibly automate measurement procedures. The problem with robots, industrial robots, is they are 6-axis machines. That means they are not rigid like the conventional C-type, A-type, B-type machines on the market, which are 2-axis machines. That means the robots are kind of like this puppet. If it didn't have the supporting wire to hold it up, it would collapse. And whenever when it moves its arm, this puppet, it has 6 axes to move it. And that means it's very difficult to ensure that the puppet is actually moving on a photometric coordinate system, a C-type, an A-type, or a B-type. That means moving all the time on latitudes and longitudes without deviation. Robots are not designed to move only 2 axes. They move always 6 axes for any movement they conduct. So this is quite a challenge. What LMT has done is it has, and then robots, but the advantage is, of course, that because the robot has 6-axis movement, is that it can take a wide variety of test samples, and it can always move these test samples automatically into the optical center of measurement. This is an example for automotive rear lighting. This is an applique, a combination rear lamp with signal lamp, with brake lamp, with high mounted turning signal, all in one LED package for an Audi. This is, for example, an explosion-proof LED luminaire, very large, weighs 120 kilograms, and a robot can actually move this object with an accuracy of 0.05 degrees. And what LMT has done is it has taken these robots and it's developed its own control system, which allows 2-axis movement. And this means what we are able to do is mount the test object in a very comfortable mounting position So you can imagine in this film that you are the operator standing in front of the goniometer. You have mounted the system. This test object is placing torque on the 6 axis, and it's influencing the angular accuracy. The machine will measure the influence of the torque of the test object, and the motoric movement of the 6 axis will compensate for any out of axis movement because of the torque. Then it will move with the 2 axis into the testing position. And now we see the big advantage. That means a very large object. This Audi rear combination LED, full LED lamp is 2 meters wide. And the target is the target of optical axis of the photometer or the spectrometer or the color meter that is actually working as a sensor with this goniometer. We can move the robot to an optical axis in the middle of the luminaire, to the left side, to the right side. And each of these new optical axes, the goniometer will perform the distribution test for that particular light source. That means I can mount this object once by means of an electrical multiplexer, connect and stabilize all light sources on this single rear combination lamp. There's 15 different light sources, and then make a software program where the robot actually measures all of these functions separately, but automatically, according to what is necessary to be measured. And this is a short film that will show exactly how we've solved the problem. This is the mounting position. To mount the luminaire, does a torque test. Now it moves into the measurement position using 2-axis movement. It will actually do the scan of the distribution of the left side and then the right side. So and we're very proud to also be able to announce that the first Indian customer for this machine will be Yakwar Lighting in Delhi. The machine will be shipped also in 2 weeks' time to Delhi. That means soon one of these actually most modern of any type of gonio-photometer in the world will be soon in operation in India. The next topic, I'd like to just go into a little bit about automotive lighting testing, what's happening in this region and with the developments for gonio-photometry. Automotive lighting has profited from LEDs, I think, most of any of the sectors of lighting. That means as far as design is concerned, because the LEDs have really allowed the lighting designers to create the most magnificent solutions for lighting, in this case automotive lighting, and making also the lighting fixture on the car to be one of the most important styling elements. Also, as a functional element, the LEDs open up for automotive lighting huge new possibilities. And the most important aspect of this is the so-called AFS systems, or adaptive driving beam systems, matrix. That means these are LED headlamps with a number of pixels, where each lighting function can be controlled by a single LED, or actually by pixel at the pixel level. And that means automatically adapting to the road situation, to oncoming traffic, to stop glare. This is something that is in great use in Europe, and it will be a component of any kind of lighting fixture for cars in the future. These fixtures are developed with the help of A-type goniometers. As I said, there are about 14 of these machines, laboratories working in India today from LMT. An A-type goniometer is a very high-speed goniometer, which is scanning basically a half hemisphere of the forward emitting part of the headlamp against a photometer at 25 meters. The information that is generated are beam patterns, 2-pi beam patterns on a screen at 25 meters. And what we want to do is design headlamps that provide enough illumination on the road, but do not blind oncoming traffic. And because these headlamps are becoming so complex due to the LEDs, there are many functions now integrated into a headlamp. Each of these functions for homologation, for approval, needs to be tested on a goniophotometer. And whereas you used to be able to test a simple headlamp within a half an hour, based on a halogen bulb, today an LED type headlamp takes at least 1 week to characterize on a goniophotometer. This means that the industry is under a lot of pressure to speed up measurement times. The problem is that the A-type goniometers, they move 50 degrees per second. They have a scanning resolution of 0.01 degrees. It's almost impossible to increase this measurement speed anymore. They have reached basically the limit, the physical limit, technical limit of their possibilities. So the idea is, or the question is, how can we gather the distribution information in a much quicker way than actually scanning line for line, 0.01 degrees higher distribution of a headlamp. And the idea is to switch from direct goniophotometry, which is conventionally done, to so-called indirect gonophotometry. In indirect gonophotometry, we place a screen between the photometer head and the headlamp, and we integrate a CCD camera, which is actually aimed at the screen, and the CCD camera is taking photographs of the distribution that it is seen on the screen. The camera, it's just like taking a panoramic photo. That means the screen is actually, the size is limited due to the space and available space in the laboratory. The screen might be 6 meters wide, 3 meters high, and that this way you will see a portion of the distribution. The goniometer is positioning the test object with respect to the screen. The camera is taking a photograph of the image that it sees on the screen, and a photometer is correcting the spectral mismatch and the stray light that is intrinsic in the CCD camera. Here we see the typical room layout with the goniophotометр and the addition of this observation screen at 25 meters. The goniometer positions the headlamp at the first angle of observation. We see a cutout of the complete distribution. The camera takes a photograph. A new solid angle of interest is then positioned at the goniometer. The right side of the distribution, for example, we take a photograph. Then the goniometer moves to the left side. We take the left side of the distribution. We take a photograph. And then per software, like when you're using your mobile phone on vacation and taking a nice panorama of the Taj Mahal, then you are stitching these photos together into a complete distribution. The aiming of the headlamp, which is an issue for automotive lighting, is done automatically by means of the camera. And then we can place the actual points of the regulatory measurement points on top of this distribution, and subsequently measure only at particular points of interest with the photometer, which has a much higher photometric accuracy than the camera, to get the correct distribution information. So this way we can stitch the entire distribution together, and we can correct any of the errors in the camera measurement by point measurements that are being made against the photometer, the conventional photometer. And we get a full beam pattern with perhaps 16 images made by the camera at 25 meters. A test that used to take at least 1 hour by scanning it photometrically now takes about 4 minutes. And because of the correction, we see here that there's no difference in the quality of the data that we are gathering. This sort of technology will also be used or is going to be increasingly used in evaluating so-called real car distributions. That means we are actually driving a car into the laboratory, into the A-type goniophotometric laboratory, and positioning the car in front of the screen, and with help of the camera, also measuring the distribution that we are seeing. This is an important issue because it has to do with the actual, what is conventionally done are component measurements. We are doing component measurements on the A-type goniophotometer, but there is a difference between the component distribution being measured individually and the components when they are actually built into the automobile. So we want to know also more and more the actual distribution in the car itself. The future, and this is going to be the next generation of LMT goniophotometers, is a so-called GOL model, and this is a full-scale goniometer which you can drive the car onto the goniometer, and you can actually do the goniometer is moving the car horizontally, or the distribution that is being sent against a screen at 25 meters. And we are taking photos and doing the same kind of stitching that we would be doing with the automotive headlamp component, but we are doing it with a real car. It will be the next generation of LMT goniometers. The first one system of this will be going into a Chinese test institute next year. Yes, and that's just a short review of some of the most recent things that we have been doing in gonio-photometry, and I thank you for your attention.
Thank you, Mr. Dale, for his excellent presentation. And you have shown to robotic mirror gonio-photometer to automatic gonio-photometer live situation. Thank you very much. Then we'll come back to the question.
Okay.
Now the presentation will be Mr. Balaji. He is the head of technology development, Hynetic Electronics. Mr. Balaji is having 14 years experience in product design and development in various product and semiconductor industry. Presently, Mr. Balaji is working as head technology development in Hynetic Electronics Private Limited, which is the leading player providing the IoT solution. In the past, Mr. Balaji developed various applications, including smart connected outdoor and indoor lighting system, smart energy meter, connected IoT gateway, automobile infotainment and communication solution for electric vehicle changer and smart consumer. Now, with this background, now I request Balaji to take over. Thank you.
Thank you, Mr. Chakravarti sir, and thank you, Dale, for a wonderful presentation. Let me share the screen. I hope you are able to see my screen.
Yes.
Okay. So, thank you all for attending this. Today I'll be talking about this subject, digital touch to LED lighting using IoT technology. So I'll be covering a short brief about our company, 2 slides. Then I'll be touching about a brief about Iot Basics, because I'm considering this session as a training cum informative session. I understand a lot of participants are from different background. So some of them already knowing the basics, some of them are not knowing the basics. So I want to cover, present considering both the people. So then we'll be talking about outdoor, smart lighting, indoor, cloud considerations, a thought on smart city focus applications, especially for India, and some more on technology stack and the appendix. So Hynetic incorporated in 1989 as the first India origin semiconductor distributor, and the business was acquired by Arrow and Electronics and Premium Farnell. Today it's called as Element 14 in 2008. Post 2008, Hynetic business has been transformed to ODM model, where as an ODM, Hynetic is into design, development, and manufacturing of various products, supports customers with white labeling options. So Hynetic advantage, 30+ years of industry presence with design and manufacturing expertise in embedded and power electronics domain. We have a well-equipped design center in Bangalore, product development to suit technical and commercial needs. We have circuit design, firmware development, software development, and manufacturing under the single roof. So we have offices at major cities in India. Bangalore is our headquarters, Mumbai, Pune, Gurgaon, and Hyderabad. And we also have an international sales office in Singapore. So today we are focusing on these segments: electric vehicles, LED drivers, smart home, industrial automation, smart cities, smart grid connectivity, cloud services, engineering design services. So let's move on to IoT basics. So what is Internet of Things? A simple definition is a thing connected to internet and exchanges data with another machine or server. A thing can be anything. It can be light, television, watch, switch, sensor, energy meter, water meter, a pole, refrigerator, even a dustbin in the outside, and many more. So the data transfer can be two-way or one-way depending on function of the device. For example, dustbin can be a one-way communication, whereas the light is a two-way communication device. So next question is how to connect a thing to the internet. Through standard routers and telecom base stations is one method. Using a custom gateways along with standard routers and telecom base stations is a second methodology. How to do this? You look at these technologies like Wi-Fi, Ethernet, or 2G, 3G, 4G, or NB-IoT. If a device with Wi-Fi can connect to a cloud or server through a Wi-Fi router with active internet connection, a Ethernet with network switch and router with active internet connection. If you have a device with 2G or 3G or 4G or 5G going forward or NB-IoT, use as a base station, which is a mobile base station, and connect to the internet. The second option or the methodology is using a custom gateway. If you look at the devices with Zigbee network, LoRa, Sigfox, power line communication, 6LoWPAN, or something better, even Wi-Fi. There are so many different technologies that we are going to talk in the next slides. We can use a custom gateway and communicate to the server or another machine using this same. If you look at this section, it remains same for both, but the only difference will come into the in-between communication methodologies. A device with Zigbee uses a Zigbee gateway. A device with LoRa uses a LoRaWAN gateway. Similarly, a device with power line communication uses a power line gateway. So let's look at IoT functionality, a design and the design considerations. If you look at this, these are the main features which we need to consider whenever we design an IoT system, like discovery, identify, adopt, and manage the diverse transports, interoperable, exchange of information, and security. So let's move on to smart connected lighting, outdoor and indoor. First of all, why smart connected lighting? Why it is required? To save energy through dynamic and scheduled dimming, helps to simplify process of maintenance and reduce maintenance costs. Asset tracking and maintenance management, take stock of millions of city assets using IoT technology. Public addressing and alerts as lights are available everywhere. Value for money, to improve product quality and service and bring accountability. Improves city or workspace or people's experience with these IoT solutions. Data collection and analysis. Data is the new gold. So let's move on to architecture and connectivity option for smart connected lighting, especially for outdoor. So we will be discussing on these options for outdoor. Look at this slide. First, we need to understand how the lighting system, especially the outdoor street lighting, is distributed across the world. It uses something called as a switching point controller or a feeder panel. This powers up the lights in that particular stretch, either using a single phase or three-phase system. And there will be a feeder gateway or RF plus feeder gateway, in this case of a RF mesh topology, which performs on and off and monitors the group level energy level. And this communicates to the cloud using 2G, 4G, Ethernet, or Wi-Fi, or optical fiber communication, or NB-IoT, whatever the communication available at that particular stage, at that particular site. So each and every light will be having a RF SLC. So now what is RF? There are two frequencies we can use for RF mesh topology. 2.4 gigahertz, which is worldwide license-free band up to 1 watt of power. 865 to 867 megahertz, which is sub-gigahertz range for India license-free band. If you want to have it in Europe, you need to go for 868 megahertz. In US, it is 915 megahertz. In Australia, it is 915 megahertz. So it depends for a sub-gigahertz, but 2.4 gigahertz, it is worldwide license-free band up to 1 watt of power. So if you look at this protocol, Zigbee, the protocol could be Zigbee, 6LoWPAN, Wi-Fi, DigiMesh, TinyMesh, etc. It all builds based on 802.15.4 standard. It's a self-forming and self-healing network. Strong private local area network is possible. You can have 250 plus nodes in a single network under a single gateway. Practically limit the hops to maximum 8 for a stable network and communication. Gateway to ratio can be determined based on the site conditions. Please note, we can't break laws of physics for any reasons, for any commercial reasons or any reasons. And this RF mesh is suitable when all consecutive lights are RF enabled, not suitable for randomly distributed smart lighting implementation. It cannot be like, few lights with the RF, few lights are not with the RF in the same stretch. The RF mesh won't work effectively. So the RF mesh extends communication range automatically. You can also add additional RF gateway in case of larger light count under the same feeder. So the number of lights under the same feeder can be 100, 200, even 300, even 50, depending on the kilowatt rating of the feeder. So other option to connect the outdoor lighting to the internet using a Wi-Fi, this section remains same. The concept of wiring remains same. In this case, each and every light point will be having a Wi-Fi enabled CTEC controller. You can see this frequency of either 2.4 gigahertz in case of single band. In case of dual band, it is 2.4 plus 5 gigahertz. If you look at the protocol, Wi-Fi, this is the standard. It's automatically plugs in to the nearby access points. Use Wi-Fi extender or multiple access points to extend the range. High bandwidth and throughput. Camera integration is still possible with this because of the high bandwidth availability. Access points are easily available at low cost. This architecture is suitable for campus lighting or any street where outdoor Wi-Fi coverage is seamlessly available. So next comes to the LoRaWAN. It's a long-range, low-power radar network. If you look at this architecture, you can have a streetlight controller in each streetlight, which is LoRa-based. This connects to the server through LoRaWAN gateways available. Deployment of private or own LoRaWAN network is still possible. Please make a note. You no need to always depend on the service providers. You can have your own network. So if you come towards the frequency, in India it is 865 to 867 megahertz. For Europe it is 868, and for other countries it differs the frequencies. If you look at the protocol, it's a long-range LoRaWAN, low-power wide area network. This is the standard, and this consumes a very less power. Good for battery-operated devices and solar-operated streetlights. It's a low throughput and payload. There will be some limitations in uplinks and downlinks in a day. Operating expense is high because the charges are per node basis every month. Gateway count depends on geographical areas and light count. Approximately around 1,000 lights. A single gateway can handle around 1,000 lights here. Again, we cannot break laws of physics for any reasons here. We need to have multiple gateways for a proper communication. We need to understand the field scenario before we implementing the solution. And it is suitable for both scenarios where all consecutive lights are smart, as well as for a randomly distributed light implementation, because it's a wide area network. If you move towards GSM or NB-IoT solution, so GSM, we have a 2G, 3G or 4G, because 3G and 4G are expensive, 2G is sufficient. There is something called as the NB-IoT, which is narrowband IoT, a very upcoming technology in the world. Again, in this case, you can have a deployment of your own or private NB-IoT network is still possible. You no need to always depend on the service providers in any of the part. If you wish to have a own network, you can have it. SIM card to be used in each smart light controller here. Again, it automatically plugs into the nearby base station. Easy to deploy, network widely available across the globe. Again, this is little bit operating expenses is little bit higher than compared to RF or power line communication, because you need to pay for the SIM charges every month. Network challenges are some RF black spots, example, like under the flyover, tunnel, vegetation area, basements. This is also suitable for both scenarios of where the consecutive lights are smart enabled or even randomly distributed light implementation. So you can also go through this. It is different frequencies are available for a quad band and dual band and the NB LT CAT NB1 and NB2. So this is also one of the wonderful technology. If you look at this, another way of achieving a smart lighting outdoor using a power line carrier communication. The data being transmitted through AC power lines, no additional wiring is required. This is also one of the beautiful technology which can be best suited for street lighting application. So there are two types of power line communication technologies. One is broadband and narrowband. You can see the difference here. The frequency at which it works is between 2 megahertz to 30 megahertz because it's a low ambient noise band, 100 to 200 kilohertz in narrowband, high ambient noise band. And these are the standards. So if you look at the protocol, whether it's called HomePlug Green5 or HomePlug AV, G3R Prime, IEEE 1901 is the standard. These also have network formation. It's a self-forming and self-healing network. This also gives a strong local area network. You can have 253 nodes in a single network. There are 750 nodes are possible under a three-phase system here. And practically, you need to, again, limit the hops to 15 in this case in a single network. But in the same power line, you can have multiple networks. There is no restrictions here. And it is also suitable only for lights which are consecutive smart, not for a random distributed lights across the city. Means, if you have a 50 stretch of lights in a single line, all 50 should be in PLC SLCs enabled. So each PLC SLC supports repeater functionality to extend the range. So it repeats the signal so that the data from the first point even to the 1 kilometer away, 2 kilometers away, it is possible to transmit the data easily. Yes. Quick technology comparison. See, I want to tell you very clearly that we can't say that one technology is superior than other. Every technology has its own pros and cons. We need to select the technology based on technical feasibility and commercial sense. This comparison is only to understand how the difference is. So we have already discussed about this. I want to have what could be the control latency? These are all the common questions which you will be having. Control latency in case of a RF, because the communication from the server should reach to the gateway, from gateway to the lights. It will be around 10 seconds to 3 minutes. Here it will be quicker, like 5 seconds to 3 minutes. Still quicker. It depends on the all the network coverage here. In case of PLC, same as RF. In case of LoRaWAN, also quicker. But again, it may go up to 20 minutes. Also, it again depends on the traffic at that particular gateway. So you should have multiple gateways to have a proper communication. So periodic data collection is possible between 8 minutes to 15 minutes. In case of a NB-IoT, 1 minute, as low as 1 minute, here also as low as 1 minute, but it depends on number of uploads per day. The deployment in the field is very easy in case of NB-IoT and LoRaWAN because you just plug in, it connects to the nearby base station and works. In case of a PLC and RF, you need to have a commissioning, form a network in the field, connect it to the gateway and move on. So now the normal street lights poles are moving towards smart poles. It's a wonderful concept coming out for each and every city. I have given two smart poles here. One is a telecom smart pole, one is non-telecom smart pole. These are all common factors like smart light, smart surveillance, electric vehicle charger, environmental monitoring, digital billboard. This gives a lot of revenue for the people who implement smart pole, Wi-Fi access points, emergency call box, public address systems, flood monitoring and water logging. And in case of a telecom pole, you can have 5G or LTE small cells. You can also have enough power backup, and you can have an EV charger. Now, next 5 years down the line or 6 years down the line, you will have a lot of electric vehicles in India. So smart pole is going to be a big business model in India, even across the world. Now let's move on to the indoor options for connectivity. So we'll be talking about power over Ethernet, Wi-Fi enabled, how we can achieve an indoor lighting system with different technologies. So we talk about RF, we will talk about BLE mesh and all these other solutions. Now let's talk about power over Ethernet. So these are all the standards available. In case of type 3 and type 4 PoE++, you can go up to 100 watt per port. A switch with type 4 PoE++ capability can give 100 watt per port, and it can, at the device level, you can get up to 71 watt. Like this, these are all the power available depending on the wattage. So if you look at the architecture, there will be you can have a local or a web-based application server, a PoE switch connecting to the PoE controller and the driver through Cat5e or Cat6. Don't go below Cat5 cables, it cannot go to work. And it connects to the fixture. You can also have sensor interface like occupancy sensor and ambient light sensor. You can have a dynamic lighting based on this. So it's a high, stable and secure LAN. Power and data in a same cable. Safe building, no OEC power lines are required. Implementation of human-centric lighting is very easier with PoE. It's a high bandwidth and throughput. Both cloud and local server implementation is possible. The capex is little high because of the high price PoE switches. Retrofit is difficult in this case as wiring changes are required. So application areas, office spaces, data centers, secure and safe buildings. Look at this Wi-Fi. So these are all the standards with different frequencies and different bandwidths. You can easily see this. Again, the implementation wise architecture, you can see the application server, a local or a cloud, a Wi-Fi standard router with the internet connectivity in case of a cloud, with the local connectivity in case of a local server. You can have a Wi-Fi control driver and connected to the light. In this case also you can have occupancy sensor, ambient light sensor, implement dynamic lighting. So look at the advantages. It's all Wi-Fi is widely available. Access points and routers are also widely available. Upgradation and retrofit is very much possible here. Implementation of human-centric lighting is quite easy. High bandwidth, high throughput. Both cloud and local server is possible. Acceptance in corporate office is little challenging because Wi-Fi sharing is not feasible in that case. So you can use this for retail spaces, data centers, home lighting, and warehouse or a smart home or a smart office, a smaller smart office lighting. Again, we come to the RF mesh. See, we already discussed about RF mesh topology, which forms a routing table with lot of in between connects to extend the range. So in this case, a RF controller with Wi-Fi, the RF controller with driver connecting to RF gateway, connected to the management application. This is the architecture. Like other technology, you can also integrate a sensors, occupancy or ambient light or any other sensor. You can add environmental sensors also in this case, collect the data. And this is well suitable for office spaces because it's a local area network. Corporates will definitely accept this. Data centers, warehouse, retail lighting, and home lighting. Look at this other solution now with the implementation of a BLE 5.0. You can have a BLE mesh topology where this is the architecture. You can have a smart driver with BLE connectivity with a BLE gateway or a BLE control switch. Again, you can have sensor interfaces. You can form a mesh, and with the click, you can control your device. Human-centric lighting is implementation is still possible here. Adaptive lighting is possible, and it is good for office spaces, data centers, and home lighting again. So smart indoor lighting with the centralized multi-output LED driver. So this is also new concept getting very popular across India, even across Europe. If you look at this, there will be a 8-port or 24-port LED driver. I would say the units are available. No drivers are required at the LED level. Only LED load is sufficient, and you power up all 24 or 8. Depending on the type of switch you are going to use or the unit you are going to use, it will going to power up. And it also got Ethernet or Wi-Fi connectivity for people to control their devices. So very much required for any office lighting and data centers, warehouses, and the retail applications. So this is, another good concept where it's called a centralized multi-output power supply being used. If you look at this, there will be 6 or 16 or 24 port multi-output AC/DC power supply, but you use a DC/DC LED driver at the light side to get the power. So this is like an alternative low-cost option to PoE switch, because the cost of this will not be as high as the PoE switch, where you still powering the system with the DC lines, which is safe, like 24 volt or 48 volts DC lines, and you achieve your automation. And this also got Ethernet or Wi-Fi connectivity to bring in the automation in the office spaces. Those quick technology comparison, we already discussed about this. So I just want to add the latency. It is medium here. It is very low, means faster latency for a command. It's also medium to low. And PO is also very faster. If you just apply a command, it works seamlessly. So size of installation, you can also have up to 200 for gateway. You can have 30 to 200 depending on the Wi-Fi router configuration. But still, you can add more gateways and more routers. Same case with BLE. And PoE is also depends on the switch power and port capacity. Again, we cannot say one technology is superior than other, because each and everything has its own pros and cons. So coming to the human-centric lighting, I will just briefly tell about this, because Mr. Chakrabarti, after this session, will be giving much more information about human-centric lighting. So if you look at this, lighting has been known to affect people's mood, motivation, well-being, and productivity. HCL solutions can support circadian rhythm, enhance concentration, prevent sleeping disorders, improves workspace experiences. You can have a color change system from warm to cool, neutral, any between 3000 Kelvin to 6500, even to 10,000 Kelvin CCT, as per the outdoor lighting conditions using some sensor, or even on the time of the day solutions. And you can also control the intensity depending on the time. So HCL solution is not just needed for office space, it is very much needed for home lighting too. You can just see at different time how you can play around with your CCT and intensity. So I just want to touch upon cloud and server considerations, a generic top level information, how you should consider that, because it is very important for IoT connected lighting, both indoor and outdoor. You need to consider redundancy. You need to address security. Sufficient bandwidth should be available for, depending on your total current connections, concurrent connections, and data transfer needs. Data backup and storage, have data storage at multiple locations. Scalability, both horizontal and vertical scaling should be there. Decide a server or cloud spec based on application requirement. Don't overkill, or even do not have a under design system. You should have a power backup and power maintenance in case of on-premise server. Design IoT system such that it minimizes the load or a number of concurrent connections on the server light. Ideally, you need to have a flow like this: end device to the hardware aggregator, then application-specific server, then to the cloud, department-specific server cloud, then city middleware cloud integration platform to the city major data center. We'll be talking about this in the next slide. So it's just because I see a lot of participants are there today. Many are also from direct contact with the smart city applications. I just want to give my thought process on smart connected city. This is for a brainstorming, and it would be helpful for our discussions. So what is the need of a smart connected city? To manage city infrastructure efficiently, to achieve sustainable development goals defined by United Nations, improve citizen service through technology adoption and the growing economy. So what should be the primary objective of smart city program in India? Should be people focused, to improve city infrastructure, adopt solution with long-term vision, scalable technology adoption, provide opportunity for Indian origin companies. This should be a primary objective for smart city program in India. So what could be the focus applications? We need to educate this to our customers, our end customers, your customers and your end customers also, like water quality management, sewage management, dynamic traffic management, lighting management, transportation, safety systems, public communications, parking management, good power transmission and quality systems, and environmental gas monitoring. So what points to be considered while choosing a connectivity solution to address all these applications? A bandwidth, network availability and stability based on geographical area, one-time cost versus recurring cost, and server and cloud implementations. A big picture now, a high-level view of technology stack for seamless smart city connectivity. Just imagine a city with all kinds of connected devices like this: a meter, a transformer, sensors, smart lighting, cameras, many more, dustbins, many more, with different communication mediums like this, or even 4G, Ethernet, or OFCs. It should go to the application independent specific cloud or server first. This should be talking to this. This is the hardware layer. This is the cloud layer level 1, wherein this belongs to a department or a project specific or a vendor specific servers. Then it should go to the middle layer, which is a product specific apps, where the product specific apps are running. And then it should enter into an integrated city data center or a cloud owned by the city. So the data aggregation software framework to collect consolidated data from the applications with cloud platforms through API interfaces. Then the command center and high-level dashboards are visible here, and it can be an integrated command center, it can be departmental usage dashboard, it can be emergency services dashboard. So this is the flow. We need to educate our end customers, or the city corporations, or the technical people, to keep their in their mind before they floated their tenders, because each and every department float the tenders individually, but they should define this architecture for a seamless integration. So I just want to say in the final bite, the possibilities are infinite. We all know that. I just want to bring in some information here. It's unwise to pay too much, but it's worse to pay too little. When you pay too much, you lose a little money, that's all. But when you pay too little, you sometimes lose everything, because the thing you bought for was incapable of doing the things it was bought to do. The common law of presence balance prohibits paying a little and getting a lot. It can't be done. If you deal with the lowest bidder, it is well to add something for the risk you run. If you do that, you will have enough to pay for something better. So let's give workable solution at the right price without compromising on the quality and the technology. So I just want to brief the key products from Hynetic, what we offer for smart lighting outdoor and indoor. We have NEMA based street light controller with RF, LoRaWAN, NB-OT, GFN, Wi-Fi. We have an internal controller which will sit inside the fixture. With these technologies, we also have a combo RF plus PLC in a single controller solution. We have Wi-Fi smart HCL drivers. We have smart treated gateway. We have switching point controller or a smart feeder panel. We have a basic 24-watt POI, POI LED driver, POI smart HCL LED driver. We also have 24-port POI switch. We have 24-port multi-output power supply, which I just spoke about. We also have multi-output LED driver also in our product portfolio. Apart from this, we are also in the electric vehicle and smart grid segment. We have 700 watt to 1.2 kilowatt e-rickshaw charger developed. We have a 3.3 kilowatt on-board and off-board charger. We have a communication module for CCS charging, which is very much required for public charging system, and India adopted CCS charging solutions. And we also have a PLC communication module for smart grid application like smart meters, smart grid connectivities. We also have a hybrid IoT gateway suitable for various applications. Thank you. So let's win together. Let's make India prosperous, and you can reach us here if you have any questions or for any discussions. I just want to show you before I end up some appendix of implementation for your practical analysis purpose, how you can save the power saving in. This is one of the data taken from the outdoor installation. You can see during peak hours, you can see the full intensity with full load. And this is somewhere between 7 to 9 or 10 o'clock. Then slowly this is the phase-wise reduction in the power. This is the total power reduction in the particular area. You can see the power is reduced, again reduced. You can also have more, close to 40% to 50% power savings here in this one. You can also see this, how the IoT is giving you the data here. Light power distribution across a one switching point. You can see so many lights. You can see what are the wattages distributed here. You can see a beautiful Google Map view, how the lights are in a city connected. You can see street light real-time data, like all the street light data, starting from voltage, current, power, all this information for voltage and power, cumulative energy, frequency, light on hours, intensity, operational modes. You can see alerts and warnings, something like this for a various alerts and warnings. You can also look at this, another example where you can just click on a device to see what is happening through a Google Map, access information. You can see where logs, you can see logs of every 2 minutes once for one of the light here with all the conditions here. This is the data you can get from IoT. So this is the dashboard for indoor. You can have like something, this is one of our, what you see the office here, this is where we implemented this system for our experience center. Floor wise control you can do, area wise control you can do. This is how you can see the real time status of all the lights. And once again, thank you ASSOCHAM and ISLE for giving this opportunity for us to present in front of you. Thank you all.
Thank you, Balaji, for excellent presentation. And we'll come back to the question answer session after I make my presentation. Thank you, Balaji.
Thank you, Balaji, for the wonderful presentation. Thank you.
Chakravarti Sahab,
Yeah.
share your content, please.
Yeah. Can you see my slide?
Still no.
You have given the share?
Sir, you have the presenter, right? Please keep your PPT open and click on share, then you will be able to share it, sir.
Okay.
Yeah. Keep your PPT open in the background and then click on share. And then you can select the PPT, sir.
Can you see now?
Yes, sir. Perfect. Make it full screen, sir.
Yeah. Thank you.
Thank you, sir.
Now the subject what I am going to talk about, the LED technology road mapping. Now, before I start the subject to go to LED technology road mapping, let us look at what is the LED status today. I want to divide that there are two era, pre-LED era, rise of LED, and solid state lighting. Today we are SSL era. So how was in pre-LED era, how it has changed to rise of LED, and how had changed in solid state lighting. Now in pre-LED era, it was a lamp, it was control gear. Initially all are electromagnetic ballast, then switch over to electronics, then luminaire, light management, and then you have a lighting solution. So differentiator, key know-how, sales pitch, and why customer buy. If we divided in this thing, the differentiator was optical design, lighting design solution, specification incorporation. Key know-how was optical engineering, lighting application, mechanical engineering. Sales pitch was lighting quality, ROI, and why customer buy, design, performance, cost. Then it came to rise of LED. Then chip came, package LED, then the module, luminaire, light management, and lighting solution. And then the LED was sold on the basis of LED efficacy and optical design. Electronic engineer getting more importance, lighting application, mechanical. Sales pitch still was lighting quality and return of investment. The new concept came the life cycle cost. Then it came to the solid state lighting world, chip, pack LED, power converter, LED light source, optics, luminaire, sensor, connectivity, software, IoT, and then semiconductor industry, electronic industry, optics specialist, electronics, and then it came to the software industry. So if you look at that, then the things are changing. that key know-how, electronics engineering, we have discussed. Now, the cost, design feature, and added, what can be added value. So the technology address this value for that, what can be added in the lighting technology. So this is all about the giving the briefing before we go to the subject of the LED technology road mapping. But there are few clear indications. One is a strong commoditization, then increased specialization, and new functionality came. So things have changed. So previously that pre-LED era, lighting was in the hands of the lighting manufacturer or luminaire company. And then when LED came, then the new functionality has come. So there are different dimensions has been created. Now, LED technology road mapping. If you wanted to talk the LED road lighting technology, that is the subject. So I go to the subject. So road mapping, providing a vision of the future, a time-based action. Road mapping answered the following question: where are we, where we are going, which technology to get there, what are the required resources, what are the milestone and risk. And road mapping is not the strategic plan. So keeping this in the background, we'll go to the road mapping. These are the reference I have taken while preparing this presentation. Now, solid state lighting can be divided into two parts. One is LED, another is the laser diode. Now, laser diode is one is the vertical cavity surface, and another is the end emitting laser. So LED, if you look that ultraviolet LED, visible LED, and infrared LED. My discussion will be ultraviolet LED, visible LED. There is a small display, LCD, general lighting, automatic lighting, horticulture lighting, and direct display. That is the way the visible LED goes. So the discussion will be concentrated on general lighting. So that is the background of the solid state lighting. One was LED and the laser. And in LED, we talk on visible LED and that too in the general lighting system. Now, if you look back the past, that 1987 Edison light bulb was created, fluorescent lamp, and then sodium vapor, then first LED came, and then it was the promotion and the development of LED. So LED controlled by two law. One is Moore's law, another is the Hedge law. The people who deals with the LED, this law are the very two important law. Now, what this law says, Moore's law says that the number of transistor per integrated circuit would be double every 18 months. And Moore predicted that this trend would hold for the next 10 years. And Hedge law is there will be steady improvement, and what he mentioned that lumen per watt will increase 20 times per decade, while the price will increase 10 times. So this law says processing speed will increase and price will come down. That is the electronic part. And LED says that lumen per watt will increase 20 times and the cost will decrease by 10 times. This was the criteria for the LED development, and these are still valid. Now, two laws and two Nobel Prize have influenced significantly LED technology road mapping. Now, let us look. The first is the Reinventing Lighting. These are the three gentlemen from Japan, where the Nakamura was with Nichiya. They invented blue LED, which enable bright and energy-saving white light. So this is the gallium nitrate, and with a yellow phosphor is the yttrium aluminum garment that converts that blue light into white light, and efficacy increases significantly as a result. That LED enter in the general illumination. Before that, it was on the traffic signal, it was the keychain and other places. So when the LED entered, the people strongly believe lighting industry mainly a driver for energy efficiency. and especially the advent of LED technology reconfirm the above statement. So before we go on LED, how it has helped the energy saving, we have to understand the design budgeting. This design budgeting is a very, very popular term. Those who deals with the technology, especially the LED technology. Now, the single LED gives 100 lumen per watt at 25 degrees centigrade and efficacy is 32. But heat sink, this operates at 5% reduced by as the junction temperature increases and the efficacy decreases. Similarly, driver efficiency is the LED watt by input watt, and driver efficiency varies from this place to this. Then the optical system efficiency that comes down to 85 lumen per watt. Now, if you take all together, then it becomes the Luminaire efficiency. So when we developed any product, we address the design budgeting, how to improve all these things. It is not only for the lumen per watt for LED luminaire. So this is a total system efficacy. So Nobel Award in 2014, what is gives the concept of LEDification? What is LEDification? Is that 60 watt bulb was replaced by 70 watt bulb. So this is LEDification. And LEDification, what it is given? It has given the energy efficiency. That energy has been significantly reduced. That is why everybody expects from the lighting as a energy driver. But at the same time, it has given the environmental efficiency. Now, what is environmental efficiency? The total installed capacity of all the sources, and now the 62.2% is the total power installed capacity. So 1 kilowatt generates so much of the carbon. This is the Department of Energy's figure. Thus, 1 metric ton of carbon save. If you can save so much energy, you can generate 1 metric ton of carbon. And 1 metric ton of carbon emission is equal to 1 carbon credit. In addition to that, the earlier generation of the light source, especially the mercury vapor or sodium or fluorescent lamp, it contains mercury. So fluorescent bulb can pollute 6,000 gallons of water beyond the safe drinking interval. So this is the first step of the LEDification, that is the energy efficiency and environmental efficiency. Next stage is that this is the figure is the LED luminaire efficacy projection. This is 2016 to 2025, and there are different area. This has been used for driver efficiency, fixture efficiency, overall luminaire efficiency, and luminaire efficacy. So you can see there is a steady growth of lumen per watt of the luminaire. This data is from DOE. So then the new concept came is the re-LEDification. Re-LEDification means that LED was replaced by more energy efficient LED. So this is called re-LEDification. Now, when re-LEDification enter, it has two ways. One, it can go to increase the lumen per watt. Another path was keeping the lumen per watt same, reduce the wattage. So it follows the two paths depending upon the application, the re-LEDification. Then what happens to the regular LED, I will hold on for some time and let us discuss about some of the new things. One of the important thing is the quantum dot. Now, quantum dot, all LED is the light conversion. That means from the blue LED, you get the white LED. But this conversion, that when it takes place, there is an effect on the LED color, quality, and the cost. So, quantum dot are the nanometric size semiconductor particle, which means they are about 10,000 times smaller than diameter of a human hair. Due to their very small, the light that is re-emitted when blue LED light hits the nanoparticle depend on the size of the particle. So if it is, for example, the quantum dot particle that are roughly 3 nanometer gives green light, and what is 7 nanometer, it gives a red light. So this shows the basically the graph for the different color and different the weight. Now this quantum LED can be used directly in LED package like phosphor. Available right now, it is available for the mid power white general lighting. CRI efficacy both can be achieved. Now in the existing LED, if you increase the CRI color rendering index, efficacy decreases. But in this quantum dot, both can be achieved. So far the limit is 184 lumen per watt and 90 CRI. And it is encapsulated to protect them from the moisture and other external influence that poses a great risk to functionality of LED. Application beyond illumination, including display and micro LED. Now, this is the application for quantum dot. And the most interesting thing is that phosphor-based LED, and this is a human eye response. Now, in the human eye response, and the red color is going out, but in quantum dot is come nearer. That is why efficiency increases. There is also possibility that phosphor and quantum dot can be combined, and then the LED can be measured. Now, quantum dot LED has just entered in the mid power range, and there will be a significant possibility that this phosphor LED will be slowly change over to quantum dot. Lot of research is going on. And because of his excellent spectral property, high conversion efficiency, process compatibility, the quantum dot will be very, very important. Now I'll come to OLED. OLED, O stands for organic. Now, like an LED, and OLED is a solid state conductor device that is 200 times smaller than human hair. So this gives you the fusion of humanity, and it is a great example for fusion of humanity and the technology. This is a quantum dot LED. It is a great example of fusion of humanity. Now, this is the structure. Organic LED to OLED simply means that organic material are used to create the light, and organic material is made of carbon molecules. These are the material that are the fundamental building block. So trees and bees, these are the two important things, the OLED. And scientists continues to focus on the development of new organic material to advance this technology. So how OLED makes white light? So this will be 2 to 6 emitter section, and this will be the light will be emitted from here. Now this is the blue emitter, this is the red and green emitter. This gives you the light, and this is the resultant light. So this is the anode, is that ITO, indium tin oxide, and the cathode is aluminum, and this substrate is the glass. Now this needs 24 volt DC just to start this one. This organic molecule on OLED are broadband emitter and excited directly with the electricity. There is no conversion. So thickness might be 1 to 2 mm. So LED OLED comparison, that how OLED panel luminaire, and if you consider the LED panel luminaire, so these are the difference, these things. So there is no thermal control, not required. Now this is the calm and soft compatible to look at the pure simple, thin and unique, cool you can touch, diffuse lighting, and then there is a volumic volumetric brightness, that is a total space is illuminated. That is called the volumetric illuminance. So if you go to that installation, you feel it looks bright. Now there is a observation because of the diffuse, there is a restriction on the control of the light. Now a LED can be bent. It is about the emotion. This can be bent. There can be OLED can be created different form factor. It can be used in the healthcare. It can be used in the to give a clean and natural conception residential area. So this is the efficacy. The major issue is the efficacy of LED. Right now, it is with high CRI, it is 55 to 60 lumen and standard CRI, and it is projected that it will increase to this value. This, whatever projected on LED, actually the efficacy does not follow that. But whereas LED, it follows it better in exceed. The issue of OLED is one of the thing is the efficacy. Another issue is the price. Technology on the future, it will be color LED, and tunable white LED already has entered in the market. And then the light can be controlled with the gesture control. And something is that luminaire that can dynamically change their shape and appearance. That can happen in OLED. So this technology for the future, for the OLED. Now let us go back to our conventional LED. How many ways the white light can be generated? One way the white light can be generated by converting blue light with the yellow phosphor, and there are different versions where the color combination you can have that OLED lighting, LED lighting. Now, efficacy of LED luminaire, what is projected by DOE is 255 lumen per watt with PC-LED. PC-LED means phosphor converted LED architecture, what we are using right now. Then luminaire LED will be 170 to 180 lumen per watt for the high power, and luminaire will go to 140 to 150. And then 200 lumen per watt will be possible with the greater breakthrough in LED performance. And if phosphor is removed, then it will come to 350 lumen per watt. So that was the prediction for DOE, and they have given the prediction, as you can see from the curve, that phosphor coated LED, color mixing LED, and hybrid LED, where phosphor coated LED and color mixing LED both are joined together. So the prospect will go to the phosphor LED to color mixing LED, and that was the red, green, blue, and amber would achieve in higher level. And lot of research is going on that. There are certain constraints on the color rendering and other issues. So now the roadmap for the optics. Let us look this interesting observation. LED captured the market as energy saving alternative of conventional lighting. 60 watt incandescent bulb can be replaced with 6 watt LED retrofit with 134 lumen per watt. Saving is 90%. Efficacy increases from 134 lumen to 100 lumen will save only 6%. So this is less significant. How do you get further saving? That was the question. So optics is one of the important area. Well-designed optics are also critical for getting the most efficient performance from a luminaire and for mixing color effectively. There are examples for LED optics, how precise optics create the lighting effect on the facade, and then the scalloping effect on the wall, or the stadium lighting, no pollution. So there will be a lot of work is already going on optics. One of the thing is the optical design. that the design of the optics. Second will be the photometry. Mr. Dale has discussed at length that what is the happens in the photometry, because this photometry will be important to validate that optics. And third will be the material. And the material, there will be a choice of the material where this thing and the manufacturing. So these are the four area. Lot of work is going on, and latest material is LSR 7000 liquid silicon resin. So these are the things happening in the optics form. So now I'll show you how the optics has created a artificial skylight. Now this is the installation. It is an artificial skylight using an LED light source and a layer of nanomaterial that create Rayleigh's scattering, the same phenomenon that makes the sky look blue, along with some clear use of mirror to give an illusion of distance. The result is ceiling panel that looks like a sunlit sky. So if you want to one, you need 1 meter ceiling height in your house and 50,000 pounds. This is one of the most attractive stall in the Frankfurt exhibition. There you can see as if that the sun ray has come. This is a combination of LED and optics design. It has to be seen to believe. So let us look at what is happened. Last decade, the lighting industry was disrupted by the LED technology. But now today, LED is treated as a regular technology, but it is evolving very, very fast. So lighting is moving beyond the energy saving. And that is one of the roadmap. The lighting is moving beyond the energy saving. And the next thing will go, the lighting will move beyond lighting. That means when lighting will be used as a carrier to collect the data, and this data will be useful for non-lighting application. That is the way the lighting technology will change. So LEDification we have discussed. Now is that digitization. Now, what is this one? This is the conventional lighting is going to digital lighting. This is the part that Balaji has discussed at length about the smart lighting. So I will not repeat this thing. I'll just touch some of the point. What is connected and smart lighting? Connected and smart lighting refer to the lighting installation in which luminaire are integrated with the sensor, are interconnected with the wire or wireless network to both control and monitor the lighting. That is one of the criteria for connected smart lighting. Second is the microcontroller and many sensors like occupancy sensor, humidity sensor, noise sensor are small enough can be incorporated in the luminaire. If it is so, luminaire will become a source of light as well as information. That is the thing it will move. And wireless integrated sensor in the luminaire or the pole, key part for the smart lighting. Balaji has shown is the smart pole. And sensor make each light point is data node, and data can be used for lighting or non-lighting application. So the process for lighting going beyond lighting has already started. So connected smart lighting such as can be used for many more purposes than energy saving. It can change the color, which is linked with the human-centric lighting, data on actual use of space, sensor, humidity, temperature sensor. So smart lighting become the heart of a smart building. And that is the way the smart lighting will go. And at a glance, if we look at that, Controlling light with the voice used to be something only a God could do. Now Alexa can do it. Occupancy sensor, overview of the smart lighting control, smart telecom pole, then network topology, occupancy sensor, daylight sensor, and PoE. These are the things we'll control, and this has already been discussed. So if we look at the total scenario of the lighting, what has happened is LEDification has taken place, then optics utilization, then control, then form factor, spectrum, wellness, lighting will move beyond lighting and beyond human means horticulture lighting. So these things are connected, and this is known as HCL or human centric lighting. So this is the way the lighting is going. Form factor is the shape of the luminaire. I have shown you some of the form factor for OLED luminaire. So biological clock is one of the important aspects. Artificial lighting extended the time of wakefulness after dark and enabled the work at night, that disturbing the human circadian rhythm. That is one of the major issue today. Non-visual effect. This is the new concept of the non-visual effect. Understanding the physiological mechanism of visual and non-visual system may be used properly, and spectrum engineering and the smart control gives to the human-centric lighting. In short, this lighting concept focuses on human, their need for well-being, mood, performance, and health. And by incorporating visual and non-visual effect of lighting. So this is all about the human-centric lighting. So I have mentioned two Nobel Prize. The first one was 2014 and the second was in the 2017. Discovery of molecular mechanism of circadian rhythm. This was in the adapted to the rotation of our planet. And but now how does this work actually work? These three gentlemen, Hall, Michael, and Young, they were able to peek inside our biological clock and finding out the working, and this discovery has led to the human-centric lighting. So this is an interesting observation. The mimosa plant brought in front of the sun, it comes. When it is dark, it stops, but continue to follow their normal daily rhythm even without any fluctuation in daylight when it keeps in a dark room. And that was what is the circadian rhythm. So what is super chiastic nucleus and what does it do? The circadian rhythm are biological pattern that closely follow a 24-hour cycle. The term circadian comes from the Latin word around and day dim. And circadian rhythm govern a large number of our biological processes in eating, drinking, hormone release, and all it related to the daylight in terms of intensity, in terms of the color, and this suprachiasmatic nucleus, in short, it is called SCN, houses a type of biological that is able to keep our circadian rhythm on close 24-hour cycle. And that is the way our daily rhythm changes. And for this circadian rhythm and to make our biological clock effective, non-visual lighting effect is very, very important. So circadian rhythm gives rise to the constantly recurring changes in evaluation result in human being develop the circadian system. This is a system of internal clock which control 24 hours of all bodily function. Now, disturbing it can have a variety of negative effects, produce the symptom of disorder such as depression or immune disease. So, just as for physicists, the dual nature comprises electromagnetic wave as well as the photon. Similarly, for the duality of the light, for a physician or lighting designer, compromises of visual and non-visual effect of lighting. So that is the two important aspect. So non-visual effect of lighting, we are not aware of it. It control our alertness, circadian rhythm, pain, sleep, mood, comfort, and experience. And visual effect of lighting, we are all aware of it, that it is our visual acuity and aesthetic. Now, let us look back our daily day. Evening, it gives the feelings of meditation. Morning gives us the freshness. Afternoon, it sometimes siesta. Twilight, nostalgic. Evening, relaxing. Dark light, fearing. Moonlight, romantic. Now, this all we know. It intensity changes, color changes. In terms of the color temperature, it changes. It gives alert, energetic, absence of light, moonlight. No, now these are the concept which is happening every day. We are aware of it. These have been implemented with the artificial lighting by creating that spectrum, color, and intensity to not to the scale to create the same effect in the indoor. So the gentleman is the Russell Foster. He is the chair of circadian neuroscience at the University of Oxford. He is a discoverer of third receptor. The element in our eye that is responsible, like rod and cone, is for vision. But non-visual, the third receptor, regulate our body clock. And this third discovered at the turn of millennium, this is known as SCN, and this is called ganglion cell response to the visible light in the short wavelength, wide visible spectrum range. That is the non-visual effect of light. This is the ganglion cell. So far we know rods and cone. Rod is for the daylight, rod is for the night vision, and cone is for the daylight or color vision. So like rods and cones, these ganglion cells are found in the retina. They respond wave blue region to the spectrum, which are about 480 nanometers. So the ganglion cells especially sensitive to blue light component in the lower portion. They are not involved in the visual process. However, they have served as a signal to start the biological clock. At daylight, blue light can give a stimulating effect, energized, alert, but blue light at the night can stop the melatonin secretion, which is the sleep hormone, and affect our sleep significantly. Therefore, the highest lighting product design, manufacture implementation to to adjust visible the spectrum design, light color, intensity control with this. And that was the theme of the human-centric lighting. So we have two pathway for the light. One is the image forming, that is the visual perception. Another is the non-image forming, is the circadian rhythm, that is basically for the blue light. So for a long time, it was not known the relevant light stimuli are perceived, but in 2002, scientists discovered in the retina, unlike rod and cone, however, its third receptor function is not visual, and this is known as the ganglion cell distributed over the retina. And the photoreceptor is that what we are for the rod and vision, and melanospin is the thing which deals with the ganglion cell or our biological clock. Now, daily circadian rhythm is a fundamental property of human life, as synchronized by natural 24-hour dark light rhythm. And entertainment of light is affect the biological effect of the light in a particular rhythm, supplying the energy to the body. That means it gives you the glucose increased and you feel. And at the night time, when there is no blue light, it will enhance the melatonin and increase the sleep. A relative new type of this one, and this is the ganglion cell, and this is shown in the black arrow is the SCN means is our biological clock, and small arrow shows us the ganglion cell. SCN is a pathway to pineal gland where the melatonin is produced, and adrenal cortex responsible for production of the cortisol, which makes our energetic. So today, people in the world, industrial nation in particular, spend most of the time both during the day and night in the room illuminated by artificial lighting. So biological effective illumination design guideline is one of the most important, and only that standard is available from the DIN. Please look at the standard. It gives the exactly how you have to utilize this one. It is actually it is a static lighting environment. People experience does not experience sunlight with little or no dye. Lack of exposure to the sun spectrum can interfere the body natural cycle, and these are the problem that what we feel, that daytime we feel that sleepy, and nighttime we cannot sleep. This is the one of the major health hazard. So natural light is a dynamic from sunrise to sunset, but electrical lighting is fixed. So light has effect of vision, biological, and emotion. So the metric is the lux and lumen, and for the biological, there is a new concept of melanopic lux. Now, human need light. Our body produce hormone in response to the absence or presence of blue light. This hormone regulate our international clock. Absence of light in the evening makes us sleepy, and daylight makes us alert. So this is the interrelation between the lighting and the possible human effect. And this shows the different lighting at the time, hours, and the color temperature. And also it shows how the intensity will be reduced. So based on that, this thing that human-centric lighting has been worked out. So if we look at that non-visual response to the light, we have one is the photopic light, means the daytime light where our cones are active. Scotopic light is the nighttime light when our rods are optics, and melanopic light where our ganglion cell, which is known as the IPGRS, are active. And this is rod, this is cone, and these are the ganglion cell. So melanopic ratio is important. If you know the melanopic ratio, and if you measure the regular lux, that is the photopic lux, then by multiplying melanopic ratio, you can calculate the melanopic lux. So the DIN has given you the different values. So now the LED manufacturer, they give the melanopic ratio. They have developed the special LED. Number of vendors have developed the manufacturer that developed LED exclusively for human-centric lighting. So what is required? It is required as at a eye level 1.2 meter melanopic lux will be around 200 lux, melanopic vertical lux. So you have to calculate the vertical lux, and then you have to convert it by melanopic ratio to achieve the melanopic lux. So these are the different hardware will be required. One of them is that this is a single LED chip where the color can be temperature, can be changed, melanopic ratio is available. There is a control system, and at the same time you have a software or the app by which you can control. That is the way the human-centric lighting is going, and it will go on and mature this one significantly. So where it can be used, light therapy, nursing home, office, school, hospital, aircraft you must have seen, wellness, hotel. There are a number of applications where it can be used, and many studies have been carried out. So at a glance, if you look at the human-centric lighting, you have to understand what is the non-visual lighting. You have to understand the human-centric lighting. You have to understand the circadian system. You have to refer the standard, DIN standard, and you have to make a product which is tunable with the time it changes the color. So I am now almost at the fag end of my presentation. When the Edison bulb came, it was the famous statement, the room is equipped with the Edison electric bulb. Do not attempt to light with match. Simply turn on the key on the wall by the door. Today, Thomson Edison was maybe wrong. Room is illuminated with the human-centric light. Do not attempt to switch on the light. Simply enter. The room will be illuminated once we enter. And that is the travel for the technology. And now this is the projection, that LEDification to intelligent lighting to human-centric lighting. And there will be a circular economy also. And that is the important part. I have written this one, this circular economy. There are two standards which are important and you must have. One is the wellness standard, the building wellness standard. Now there is a green building standard. It deals with the site. Wellness standard deals with the people. This is the latest standard has been developed, and it is becoming very, very popular in USA, and slowly it may enter in India, and is a biological effective illumination. So thank you and have a sound sleep, not now, but tonight and every night. Now it is open for question. I will request Dr. Barjatia to take over.
Thank you, Chakravarti. That was excellent presentation. All the three presentations were good. Mr. dealt in detail about testing, also particularly the old timers like me, when we used to handle the goniometer manually. Now it has come in the automated and with the robot operated. So he has covered the whole arena with that one. Then Mr. Balaji, he described in detail about the smartness, smart lighting. That's what it is said, that today you have to be smart to use the smart lighting and to develop it. From that angle, he integrated IoT with the lighting, and he described in detail about the smart lighting with the smart cities and other areas. And lastly, of course, as I know Mr. Chakravarti from last, I think 14, 15 years, he is a very good educator and very presenter. So he has explained in a very much depth about the roadmap, about the lighting, that what is the technology roadmap, how it was there in the past and how it is going to be present and how it is going to be in future. Thanking all the three speakers. Of course, it would have been pleasure to take the question answer session, but then since we are running out of time, so we already requested that all the questions, those who were given, majority of the questions are given by Mr. Amit Kumar Mittal, with the chief engineer with the MES, and he has got number of questions for all three speakers. So we have requested him to that he will send by email, and then we will get in touch with all the speakers, and he will reply to that. Just I've got some general questions for Mr. Chakravarti, which I would like to address to him. One is how good is Indian standards when it comes to testing the performance of LED lamps in the context of residential sector? Mr. Chakravarti.
Yeah, LED lamp, Indian standard, basically all the standard are adopted standard. All the standard are adopted, and is general practice of Indian standard is from IEC, and there one or two, 3 points we changes depending upon the Indian condition. And if Indian standard are excellent, if somebody tests the product honestly, definitely it will give the result. Only LM79 and other things have been adopted from Illumination Engineering Society North America. Now our LM79 is the version 2008. Now the latest version has come is 2019, and that needs to be upgraded. Thank you.
Thank you, Mr. Chakravarti. Now, since Mr. Amit Kumar Mittal has got number of questions, so may he hear me? If he is there, is he there? He has been unmuted and he can just put one question.
Yeah, he is there.
Mr. Amit Kumar Mittal.
Yeah, am I audible?
Yeah, please carry on.
So thank you very much, Mr. Barjatia. There are a few questions. You know, I think it will take a lot of time if I put all the questions. Now, my major point is that for Mr. Chakravarti, what is the cost comparison when human-centric LED is compared with conventional one? And is there any limitation of human-centric lighting? Like it can be used everywhere, or there are only few places which he will be recommending for use of human-centric LEDs? And another question is, okay, let me finish this. Please go ahead.
Yeah, thank you, Mr. Amit Kumar, for this question. Right now, human-centric lighting, the luminaire, which are made by using the existing LED, which are using for the general lighting purpose. Now the luminaire manufacturer, they have developed a special LED for the human-centric lighting. Means one LED you can change the color, and you can get the mononoptic ratio. These are the new technology. Quite likely the price will be higher. This is just entered. We are working on that. This one. But right now, the existing LED, the human-centric luminaire are available, and here the cost will be depend upon the control system and what are the type of the apps you go. So between a non-human-centric lighting and human-centric, the cost may not be. There will be. Come to LED, this one, it will follow the black body path. Then it will be the ideal human-centric lighting, and a lot of research is going on. So there might be some presentation for LED on the human-centric lighting. It will be a vast subject. I'll not be able to do it, but it will start, and initially for any new technology, price will higher, and slowly it will reduce.
If you allow one more question.
Okay, one question, Mr. Amit Kumar, last question.
Yeah. How far we have come forward in India about 3D printing of LED and about Li-Fi?
The 3D printing of LED is just as a starting the design process. Is not in a very big way. Some of the company are making this one where you need a LED for specific application. Every time you cannot. And the Li-Fi has just entered. I have been told that there are some Li-Fi installation in Delhi. I am not very sure, and it is just one or two installation maybe in India. I am not very aware of it.
Thank you, Mr. Chakravarti. Mr. Amit Kumar for putting away questions. And now with this, may come to an end. So on behalf of ISLE and ASSOCHAM, I express sincere thanks to all the three speakers and all the participants who joined this program in a big way. So with that, we come to an end for this today's program. Thank you, everybody. And
Thank you.
Thank you so much.
Thank you.
Thank you so much,
Yeah.
Mr. Stephen Chakravarti.
Thank you. Thank you.
Thank you.
Thank you.
Thank you, Mr. Amit Kumar. Thank you.
Thank you.
Thank you.
Okay.